How's it going? I'm Malachi Greb, CEO of Elite Automation. Here we have Peter with Piab with us today. He's going to talk to us about some suction cup technologies and just different materials and things that help you in being able to select the proper suction cup for some applications that you may have.
Hello everyone. So welcome to our booth here at Modex. We're going to talk a bit about suction cups. Ultimately here at Piab, we have a design philosophy where we like to look at the application and then design a solution that's specific for that application.
So if we look over here, we can see a variety of all sorts of different shapes, sizes, colors, materials of suction cups. Up here on the top, why don't we start here? These blue cups, for example, these are all designed to be FDA detectable suction cups. So ultimately, nobody wants to go to a grocery store, buy a piece of food, bite into it, and then have a piece of suction cup in it. Over time, suction cups are going to wear out. So little pieces of the cup could fall off. So what we do with this cup, it's an FDA silicone material, but we also have an iron that's built inside of the cup so that as a little piece of it breaks off, a metal detector at the end of the line is going to catch it so that it never makes it to the consumer. So we do these in all sorts of different shapes and sizes depending on what that food product is that we're looking to pick. Our salespeople love this because in the morning they get to go visit a bakery, get some few samples, and it smells nice. It's a good way to start the day. Over here you can see a variety of some of our cups that are designed specifically for handling all sorts of corrugated materials, whether it be a box, case erecting application, or palletizing, depalletizing. So this is a material that is proprietary to Piab called Duraflex. It's polyurethane based. What's really great about this though is that we can make these cups in multi-durometers. So this lip is actually softer than the bellows. And the reason why we do that is because in these types of applications, usually we're moving really, really fast on a robot. So we want to have a stiff bellow that can accommodate all those accelerations and deaccelerations. But we also want a lip that's going to work great on the picking surface. And cardboard at the end of the day, it's wood chips, tiny little wood chips. If you rub your hand on wood chips for half an hour, your hand's going to be pretty beat up. Same thing with a lip of a suction cup. So in order to make it so that this lasts the longest for customers, what we do is we have a really soft lip so that those little wood chips can kind of fit into here without ripping the cup up, and it lasts very long for customers. Another example right here, this is that same style cup geometrically, but it's going to be a single durometer. These are used in a lot of non-marking applications. So say you need to pick a windshield in a automotive plant. This is going to make it so that when you're driving around in the winter and all of a sudden your dashboard starts to fog up a little, you don't see a little circle on the windshield. So any sort of surface that we can't leave any sort of mark on, we're going to try to stay with a material like this that's nice and hard and it's not going to leave any sort of mark.
And these ones right here are used a lot in automotive.
These are also used a lot in automotive. So a lot of these cups are used in stamping processes actually. So if you, I don't know if you can zoom in on any of the features on the inside of this, but there's a tread on this and it's very similar to with like a car. So you're driving around again in the winter, slush, there's ice, there's snow. The last thing you want to do is go flying off the road. That's what you have treads on your tire for. Same thing with a suction cup. When you're doing a stamping process, there's usually a little bit of oil on the metal itself. So when the robot's coming in, picking up the blank to put it into the stamping press, we need to make sure that we can disperse that oil and increase that shear holding force. Again, this is something that's developed in that Duraflex material to be non-marking. We're gonna have different shapes, different amount of bellows, things of that nature. Again, multi-hardnesses on this. So again, when we come down onto that piece of sheet metal, as cars get lighter, the sheet metal gets thinner and thinner. We don't want to damage that. So this is actually softer than the lip itself so that when it contacts that surface, it's not ruining it.
Also, this edge here is sometimes used to create more stability, right?
Exactly.
After the
Exactly.
cup sucks
Increase
in.
the shear holding force. You have more contact surface area touching the product. So this is our modular suction cup family. These are called our Piab Grips. What's nice about this, it ties really nicely into really that design philosophy around focusing on applications. Today, a lot of equipment that's delivered out in the field, it might not always come with a Piab suction cup on it, but this allows our customers to still be able to take advantage of the benefits of being able to stay up and running for as long as physically possible and increase their profit margin. We do that by being able to accommodate the geometry of what that machine needs by adding or subtracting bellows away, but then specifying so that the lip is made for that type of application. So we can still have a really specific solution to what that application is and ultimately meet their needs that they need with that application.
Also, these bellow cups are really important for creating compliance in the car. So if you have an application, let's say for instance like this cup here, a lot of times you might have crash conditions, right? And you can accommodate and kind of mitigate some of the crash conditions by using a cup that has more bellows in it.
Yep. That, and then another area that we find that bellows can be helpful in as well is if you pick up a part and that part starts to sway in a really, really quick moment, this is actually going to dampen the sway over time, and it's going to make it so you don't drop your part. If you have something that is flat like this, for example, there's not going to be really as much dampening that's going to happen as if you have many balance. So it's a lot of different use cases for suction cups out there. Ultimately, our goal is let's see what that application is, and let's design something that's specific to it. That way, it's the best solution that's available on the market for the customer.
What's some of the difference between like this color here? Does the color indicate anything, or?
It's a good question. It's a really good question. A lot of times we'll use color to differentiate between a material or a hardness. In this example, this material and that material are the same, but this lip geometry is very different than this lip right here. And that's because this lip itself is designed for handling bags. So bags, think about it, there's a million different types of bags that are out on the market. And they can be different thicknesses, and they can bend and curve in all sorts of different ways.
Yeah, a lot of wrinkles.
Exactly, lots of wrinkles. Wrinkles are challenging, but with this lip, this allows us to be very pliable and form a good seal still around whatever sort of wrinkles or whatever's in the bag, so that we can get a good grasp on it and move the part safely. A lot of these were actually our original cups that we came out with back in the 70s, 80s time frame. Piab, our name comes from a drawing compass. So prior to there being computer-aided design, our first product ever was a drawing compass. And engineers would use that to make circles in their product designs. We quickly transitioned though from there over to making vacuum generators, so air-based vacuum generators, because they were a lot more efficient, a lot more quiet, and they didn't give off as much heat as a lot of the electromechanical solutions that were available on the market. And the easy complement to selling vacuum generators was suction cups. And these today are actually now our bread and butter. But a lot of these cups that you see up here, there's so many of them deployed out in the market. We still are selling a ton of them today. And even back then, we were still designing for specific applications. Like this was the original type of bag cup right here with all these pellets right here. So a lot of these were used in not necessarily this material here itself. This was used more so for food applications, but in like this material down here, for example, you would find that something like that was used on a case rack. So
yeah, I see a lot of these in the automotive.
Yeah, this material is great on really, really hot parts. So say you're injection molding a piece of plastic and it comes out at 400 degrees Fahrenheit, something like this is going to get the job done.
So you have some of your pneumatic grippers.
Yeah. So these are really interesting. We still consider those a suction cup actually. Ultimately, the only difference between this guy and this guy is that this is sealed off right here. So, when you're picking apart, you're ultimately sealing off to pick it. This is naturally sealed here already, and there's a small volume of air that we're evacuating. We're drawing vacuum inside of it, and it's causing those fingers to pinch in. Our target customer basis for that was actually, produce, so fruit like strawberries. Nobody wants to go to a grocery store and buy a bunch of fruit strawberries. So as that industry starts to automate more and more, it's good for us to have solutions that are at the ready for them, so that we can gently pick a strawberry, an apple, or a banana, and be able to, automate that type of application and save all the people that could potentially be getting in harm's way from all sorts of different machinery and things of that nature. So.
Yeah, absolutely. Also, I think one thing that's cool, you can do it with like cylinders as well, but like just having the ability to adjust like your pressure. You can adjust like the gripping strength of this.
Exactly.
And then, so if you're having any bruising or damaging of a product,
turn down a little, fine tune it in, and you're back up and running in a matter of seconds. So.
Absolutely.
Awesome. Well, do you have any other product or any other things here that you'd like to show us? Oh, maybe this is a good one. Let's go over this one real quick.
Yeah.
So these foam pads.
So sometimes you just get that product that is really, really, really hard to pick. And foam does an excellent job for us at being able to fill in all of those crevices and stuff. The application that I like to talk to this one about is typically, if you're familiar with like a heat shield on a vehicle, it's usually really, really thin aluminum and there's a bunch of bumps and curves in it. This does a great job at sealing off on things like that. So usually if we do not have something that's designed for that exact surface type, and it's a really nasty surface to grip on, this is what we're going with, because ultimately if we collapse this foam 50%, we've now made a complete seal on it. We're able to generate deep enough vacuum to start moving the part from A to B. So that's usually what we're using that for. Another really cool one down here though is these MX cups.
Okay.
So the M stands for multi, the X stands for extreme, and I comment on those because we're at Modex, and the logistics world is after something like this because all these e-commerce companies are selling hundreds of thousands of different SKUs. And this cup was designed for that type of application where we need to be able to go in and be able to pick XYZ. It could be 100 different products, could be 100,000 different products. So this cup was designed to work in an optimized vacuum solution where we have the actual vacuum flow tailored specific for that suction cup to pick anything and everything that we need to.
And can you tell people what is the reason for having these oddly shaped cups?
Yeah. So there's a couple different reasons. So one, your cup size is going to come down to what is the part that we need to pick up? How heavy is it? The more surface area that we have under the pressure differential between the vacuum and the atmosphere we're working in, the more the holding force is. So that's why you're going to see different sizes in the cups. Different shapes are going to be for different types of products as well. Say we need to pick something cylindrical. It's going to be better to go with an oval cup than a round cup because we're going to have more surface area under that vacuum. So
you have like a thin strip of metal or something that you need to pick up.
Yep.
You use something that has that same contour, and you can put a bunch of them in line.
Exactly.
Pick that.
Yep.
Thank you for sharing with everybody today and letting them know what all types of cups are on the market and some of the just different materials and shapes that people can use whenever they're designing their solutions. Like one thing that I always really liked about using vacuum cups is I could pretty easily calculate the load that I'm lifting up, right? And if my cups don't have the load that I need to lift whatever my product is, I can either add a cup, I can change the cup diameter, and now I've reached my load capacity that I need to reach.
Exactly. Very good. Malachi, I appreciate it.
Yeah, likewise.